Hello, and thank you for choosing this recorded webinar on numeric index searching in the Inspec database on ProQuest Dialog. I'm Ted Karen in the ProQuest Dialog Help Center, and I appreciate your interest in this topic. I realize it's a somewhat unusual topic, but my hope is that you will find it interesting, and also that you will find this information useful in your future searches. So, here is an outline of what we'll be doing. We'll start out with a brief description of what kind of search it is that we're talking about here today and why it is especially challenging, and then we'll show you how numeric indexing can be the solution that you need for that situation. In order to do this, we'll be searching with numbers that have to be formatted in a certain way, called exponential or scientific notation. And some of you may be very familiar with this. And if so, I don't want to bore you with a long explanation of something you may know already. But for those of us who are not engineers or scientists, I'll go through a few slides that show you how this numbering system works. After that, we'll get into some actual numeric index searches, explaining them as we go along. We'll look at two of them using slides of the searches and relevant parts of some search results. And then finally, we will do a third numeric index search as a live demo. So, what is the basic search issue that we're talking about here today? Well, if you've used ProQuest Dialog for any time, you probably know that in ProQuest Dialog you can very easily search for any specific word or number or phrase simply by typing it into a search box. And that would include things like this, just typing 10 kilograms or 2 megawatts or any of these others here. And that's fine if you are only interested in records that have that specific value spelled out in the text. But often, here at the help desk, we hear from customers who need to do something that is more flexible. Sometimes you'll need to do a search on a range of numbers or units of measure. Searches like between 40 and 100 millimeters, or anything over 10 kilograms. And this is more challenging because there will be records that meet those criteria, but that don't use those actual words. For example, a record may not talk about something that is, quote unquote, between 40 and 100 millimeters. It might talk about 50 to 70 millimeters, or maybe it just says 60 millimeters. And you would want those records. But how do you search for them? So it's an interesting issue, I think. For example, let's say we're looking for articles about defibrillators with a voltage of greater than 50 volts. How would you do that? Well, you might try something like this using plain language. You could search for defibrillat, truncated with the asterisk, within 10 words, that would be n/10, of 50V or 50 volts, or the phrase greater than 50V, greater than 50 volts. Any of these variations that you can think of, just OR them together, and you could run a search like that. But if you think about it, the limitation with doing the search that way is it's not going to get records that talk about a defibrillator with 60 volts or 100 volts or 50 to 75. What is the solution? I tried running this search just as we see it here, and I did get hits. I got 22 hits in Inspec database. They were good hits, but by running the same type of search using numeric indexing, I got 55 good hits in the same database. And here is our first example of what a search like that looks like. Here I have defibrillat truncated and NIVO, and inside the parentheses I have the symbol for greater than 5E1. NIVO is the search field, as you would see in the pro sheet for Inspec. That's the search field for searching on numeric index for voltage. And we have inside that field greater than, and 5E1 is simply the numeric indexing format to write out 50, because it is 5 plus 1 0, 50, or 5 plus one more decimal place, 5E1. And we'll be discussing how all of that works at some length before very long. But since this is a type of search that you can only do in Inspec, you may want to know something about that database and the kind of records you can find in there. So let's back up at this point and take a look at Inspec. Inspec is a database created by the Institution of Engineering and Technology, the IET, which is a learned society of engineers. They're based in the UK, but they cover works from all around the globe. They are a publisher themselves, but they also gather together and collect and index and put into this database engineering works from every place. This database goes way back to the late 1800s. It currently has some 17 million records, and they cover primarily the areas that you see here: physics, electrical and electronic engineering, computing, information tech, a lot of records having to do with modern technology, as well as records about articles about production, manufacturing, and mechanical engineering. About 70% of these records are journal articles, but it's important to know also that a good 30% of them or so are records about conferences, conference proceedings. And that is important because, as some of you may well know, the conferences where the experts get together and present their papers and their most recent research are a great place to find the information that is most on the cutting edge, what is really going on most currently. And you will find a lot of that in the Inspec database. The Inspec people also do quite a bit of indexing of various types to make the database searchable in ways that you will not find elsewhere. And one of those is what we're talking about today, the numeric indexing function. It is quite unique, as we'll see, and what you'll find is that the database uses about 47 different numeric indexing fields, and these include such types of measurements as size, distance or depth or altitude, mass, time, temperature, velocity. There's also a whole group of these measurements that have to do with computers, such as computer speed, memory size, storage capacity, bandwidth in hertz, bit and byte rates, and picture size in pixels. Additionally, there's a whole group of them that have to do with electricity, how to do searches in measurements of watts, volts, ohms, amps, and so on. There's a small group of them that have to do with sound, measurements of decibels, hertz, meters of wavelength. There's even a group of them that have to do with astronomy and distances throughout the universe. So quite a few different things. You would find all of these in the ProSheet for Inspec, and ProSheets are the authoritative resource for finding any information you need about any of our databases. And like any ProSheet, this one here for Inspec starts out with a kind of thumbnail description of what the database is about, what's in it, what the subject coverage is. It shows you that the database in this case updates weekly, that the coverage is international. It shows you what the document types are, including, as I had mentioned before, the conference coverage. And then as you scroll down, the next thing you'll see is a sample record. And under that, you will see a complete list of all of the fields in the database that are searchable. Here they are in alphabetical order. There's quite a few of them. And for each of them, you'll see the name of the field, the brief code for it for when you're doing searches in that field. And you'll see for each of them an example of how to do a search limited to that field. And so some of these are the usual or typical search fields, such as abstract and title and author, but you'll also see some that are more unusual or unique to the database. There are particular types of classifications that they use. They even index their engineering articles, not patent articles, but engineering articles, using international patent codes. So if you are a searcher who uses the patent codes, or if you will also want to be doing patent searches, that is a search method that's available to you here. But we want today to scroll down farther, and it is toward the bottom of the pro sheet for Inspec that you will find the complete list of all of the numeric indexing types. So you see here there's quite a range of them. You see bit rate, depth, frequency, mass, all these ones that we were talking about and more. And for each of them you'll see what the field code is. They all start with NI. And then for each of them it shows you an example, and we will be going through some examples. But the pro sheet is a good place to go to see what the different fields are that you can use for this type of search, and also to look over toward the right side and see how the search is formatted. So with that, let's go back to our slideshow and take a look at our first example of this format. Here we're going to be looking for 5 kilobytes. And as you probably know, 5 kilobytes is 5,000 bytes. And what the pro sheet tells us is that to search for this unit of what's called memory size, you'd use the NIMS field, numeric index memory size. And inside that field, you're searching for 5E3. That would be the number 5 plus 3 decimal places, 5,000, 5 plus 3 zeros, 5E3. So that is how you would do that search in exponential format. To discuss a little bit further what this format looks like, I would suggest to you that you stick with this simple format that we're looking at here, NIMS 5E3, but you will notice when you actually bring up the records that in the numeric indexing field of these records, the numbers are spelled out in a slightly longer, more complicated looking format. They'll look like this, 5.0E plus 03. But as the pro sheet points out, the zeros are optional, and we recommend that you do not use the plus signs as part of your search. Now, honestly, if you did the search this way, anytime I've tried it, I find that it works. But we recommend that you do the searches this simpler way, and simply don't let yourself be distracted by the fact that when you get the records, they'll look instead like this. We urge you to do your searches just like that. Now next, I'm going to be showing you several slides that hopefully will present to you different ways of visualizing or remembering how this kind of number format works. Let's start with the example of 1 megawatt. A megawatt is 1,000,000 watts. So that's a 1 plus 6 zeros, 6 decimal places after the 1. And so the way that you would format that is the field would be NIPO for power. And then it's 1E6 because of the 6 decimal places. So if we were searching instead for 10 megawatts, that would be the 1 plus 7 decimal places. 1E7, 100 megawatts, you can see here, it's 8 decimal places after the 1. So you would search for 1E8. Now you may think that that's almost cheating because we're using such a simple number as 1. So let's take it to another level and look at something that is not a whole number. What if you were looking for 1.5, 1.5 megawatts? Here is where I find it helpful myself to actually write it down, because when you write it down, you can see that you're going to want to put a decimal point here for 1.5. The number to the left of the E is always going to be less than 10. So in this case, it's 1.5. And if the point is here, how far over do you have to move it to get to 1.5 megawatts? Well, it's 6 decimal places. And so what that's going to look like in exponential format is 1.5 E6. Similarly, if it was 15 megawatts, you would start with 1.5, and by writing it down, we can more easily see that that's 1.5 plus 7 more decimal places. So you would format that as 1.5 E7. What about 175 megawatts? Again, by writing that down, we can see that we'd start with 1.75, but to get the decimal point from here over to the end, it's 8 more decimal places. 1.75 E8. Now, I think that these will get to be easier and easier as you go along, but today we'll look at these in some detail for you and hopefully help you to remember these going forward a little bit better. Now, bear in mind that sometimes you want to search on a smaller rather than a greater level of magnitude from the field's basic unit of measure. So, for example, if we were searching on size, which is measured in meters, what if instead of kilometers going bigger than a meter, what if we wanted to look for smaller units like a millimeter? Well, how do you do that? The answer is that you use negative numbers. So in this example, if we're searching for 5 millimeters, that is 5 1,000ths of a meter, which you would write out as 0.005. So that would be the number 5 with the decimal point moved 3 places to the left. Therefore, the way you'd format it is 5e negative 3. And because in this case we are searching for 5 millimeters or less, we are using the less than sign followed by the equal sign. You could also use greater than or equal to, or use greater than or less than alone, any of those combinations. And so that, in short, is exponential numbering. It's similar to what's known as scientific notation or standard index form. There are some slight differences among these, but here today we'll be looking at this numbering format as it's used in Inspec's numeric index searching in ProQuest Dialog. Now you may wonder, why exponential numbering? Why are we using this? Well, one reason is that this numbering system is uniform and standardized. Because, for example, what if we were talking about 5 gigawatts? That's a billion watts. The article itself that we'd be searching for might use just that phrase. It might say 5 gigawatts in the record. But on the other hand, the article might format that as 5 GW. Or in context, if the article was talking about various things in megawatts, it might not say 5 gigawatts, it might say 5,000 megawatts, or 5,000 MW, or any of these other variations. And we don't want to have to do a search that ORs together all of these different possibilities, when instead we can go with this standardized format like this. And if we're using numeric indexing searching, any of those other phrases, those other ways of saying 5 gigawatts, they would all boil down to just this. And using numeric indexing, this is the only way you would have to search for it. And you would get the record regardless of any of those other ways that the article might talk about 5 gigawatts. Here's another slide to help us get more accustomed to how these decimal points work. If you see 2.7E4, you would move the decimal point 4 places to the right, like this, and what you end up with is 27,000. On the other hand, if you see 2.7E minus 4, you could write that down and move your decimal point 4 places to the left, and this is the number that you would be looking at. Let's look at a couple more of these. What this slide adds for us is it lists the most common prefixes that are used for these sizes, such as kilo, as in kilogram or kilometer, mega for millions, giga for billions, and we also see here the prefixes that go with the smaller units of measure, like centi, as in centimeter, for 100th, milli, as in millimeter, for 1,000th, and so on. And you can see on this convenient slide what the numeric indexing format is for each of those. And this is the final slide in this series. It shows you the same type of information in a different way to help you visualize what we're talking about here. So that concludes, let's say, the math portion of this presentation. We will move next to doing some actual searches. Before we do that, I wanted to just point out that, as we will see here, there are 2 ways basically that these searches can be done. in searching for a range. With one of them, your results may, as it turns out, include records where the quantity being discussed falls completely within the range that you're searching on, but some of the other results may talk about ranges that overlap with the range that you're searching on. So if you're searching for 3 to 5, you may get hits that talk about 2 to 4, or that talk about 4 to 6, because there's an overlap there, and you would ordinarily retrieve those. But as we will see, there is also a technique available that will make sure that all of the hits you get talk about numbers that are completely within the range that you're searching on, and I will show you how that is done. So let's start with the first of the 3 searches, sample searches, or use cases that we'll be doing today. Let's say that we want to find articles about issues of lightning strikes to poles or towers of a certain height, and we're going to choose between 500 or 600 meters of height. Checking the pro sheet, we would see once again that the field we're talking about is NISI for size in meters, and the number 500 would be 5 plus 2 zeros, and therefore in numeric indexing format it would be 5E2, and similarly 600 would be 6E2. So the way we would do this search would be something like this. We could look for lightning within 10 words, that would be n/10, of either pole or tower, and we would search for NISI, and inside that field we put 5E2 hyphen 6E2. So I ran that search recently, and here's what happened. I got 4 hits. Not very many, but they were exact, and they were exactly the records that we were looking for. Some of them talked about lightning strikes to a tower that was 553 meters in height. One of them talked about a lightning strike to a tower of 546 meters. But see, notice, there's no way we could have known going into the search that the records that were out there had to do with 553 meters or exactly 546 meters. We couldn't possibly have guessed what height we'd be finding exactly. But by searching on a range, we were able to do this search, and we got exactly the right hits. Here are some excerpts from the 4 hits we got. I'm not going to put the entire abstracts here, but we have the section of the abstract that talks about the height, and we also have here for you the numeric indexing field. As you'll see in these records, the numeric indexing field is a separate field all by itself, and it formats the numbers in the ways that we talked about before. But notice this reference to 553 meters, it doesn't spell out the word meter. It has this hyphen here, 553M. We might not have been able to guess in advance either that that's how they would format that number. But we didn't have to guess because we were using numeric indexing, and therefore we retrieved it automatically. Here's the one with the 546-M, and we retrieved that with our numeric indexing search. So that search worked perfectly, and it got us the very records that we wanted and nothing else. Let's take a look at another one of these searches. This time let's do a search in the computer area. We're going to look for articles that have to do with Intel computer processors, and we're looking for processors that are not too slow but also not super fast. We're going to look in particular for the range between 1.5 gigahertz and 2.7 gigahertz. And by looking at the pro sheet, we can see that the field for this is NIFR, as in frequency, measured in hertz. 1.5 gigahertz, giga is billions, which is 9 zeros, so 1.5 giga would be 1.5 E9, while 2.7 giga would be 2.7 E9. So knowing that, here's how we would put that search together. We can search for Intel and processor or CPU and NIFR parentheses 1.5 E9 hyphen 2.7 E9. So I ran that search not long ago, and I got 94 hits, a good number of hits, and each one of them talked about an Intel processor with a frequency in the range that we were searching. But the exact numbers were varied. We got hits on 1.6 gigahertz, 1.8 gigahertz, 2.33, 2.6, all these different numbers, and we couldn't have known in advance how many different numbers we were searching for, but by using the numeric index range search, we got all of those and more. Here are some examples of records with 1.86 gigahertz, 2.6 gigahertz. Here's a record that is of interest because it talks actually about two different processors. One of them was a processor at a speed of 2.6 gigahertz, which falls right within the range we searched, but it also talks about a processor with 3.2 gigahertz, and that is outside of the range we searched for. But because the record does talk about this 2.6 gigahertz processor, we retrieved it. And the fact that it has this other one in there does not spoil our ability to retrieve that. So that is part of what we will get ordinarily with one of these range searches. Here's another variation. In this record, you'll notice the article is not talking about one particular single speed. It is talking about a range of processor speeds, namely 1.6 gigahertz to 3.7 gigahertz. So this range starts out at 1.6, which is in the area that we searched on, but it ranges on up to 3.7 gigahertz, which is faster and beyond the range that we searched on. Nevertheless, there's an overlap there with the range that we searched on, and therefore we retrieved this record. And I think that in general, that's what you want, that you would want to retrieve this record, and that's how it works. So that brings us back to what we were talking about before, of how a simple range search will retrieve records of two types, both records that fall completely within the searched range, but you will also get records that may talk about a range that has an overlap with your searched range, falling partly inside of it and partly outside of it. Here's a way of visualizing that. If we search for the size 5 to 10 kilometers, that's NISI 5E3-1E4, we will get, as expected, any records that talk specifically about 6 kilometers or 8.5 kilometers or 7 to 9 kilometers, because those values fall completely within this range. But we would also get these ranges that have overlap, like a record that talks about 1 to 7 kilometers or a record that talks about 8 to 12 kilometers. And as I was saying, I think that most of the time is what you want. That's how you'd want it to work. But what if, for a particular reason, you want to do a search where you would not get these numbers that overlap? What if you only want the ones that fall completely inside this range? Can you do a search that way? Yes, you can do that. And I will show you how that's done. You will not find it in the pro sheet because the method involves a basic ProQuest Dialog search method that's not really specific to numeric indexing, namely the NOT connector. And I'll show you what I mean. In order to limit your search in the way that we were talking about, you could start with your search for 5 to 10 kilometers, but then you would NOT out any records where the NISI value may be less than 5 kilometers, or any that talk in any way about a range that is over 10 kilometers. And this is what that would look like. You can just refer back to this, and this is exactly the way you would want to format your search to get that more limited result. And you would be knotting out anything that comes in under 5 or higher than 10. And that's the way you would do that in those cases where you choose to limit your results that way. Now, something else to bear in mind is that you can do the opposite of what we've been doing. We've been searching for ranges, and we have noted that sometimes those searches will retrieve records that talk about one value in the record or a range of values. But you can also do the opposite, and what I mean by that is you can do a numeric index search for a single specific number, and you will get records that either have that same number, of course, but you would also get records that talk about a range that includes that number. I think that's more easily understood with this graphic. If I do a search for 7.5 kilometers, that's NISI 7.5 E3. Kilo is 3 zeros, 5 E3. We'll get records that talk about a range that includes that number. You would get records that talk about 7 to 9 kilometers, or 1 to 8, or 5 to 10 kilometers. But notice that if you did not use numeric indexing, if instead you just did a plain language search for 7.5 kilometers, you would miss all of these hits because they don't actually say 7.5 kilometers in the record. And so the takeaway here is that numeric indexing searches are your friend, not only if you want to search by a range of numbers, but also if you want to retrieve records that talk about a range of numbers, even if you are searching on a specific number like this. Okay? And so with that, let's move on to our third sample search. This one I would like to do for you as a live demo. And here we're going to be searching for noise issues that have to do with those wind power machines that you see by the side of the highway in some areas. And what we're going to want to look for today is not articles that talk about noise. That's one of the issues connected with this type of power supply. And we don't, in this case, want to look for articles that talk about noise in giant wind power farms that go on for acres and acres, or that have hundreds of these machines. We want to be searching today for articles that deal with this technology on a much smaller scale, such as you would use for a private house. And we've done some research. We found out that what we're looking for here is these wind power machines of 10 kilowatts or less. So if we look in the pro sheet, we will see that the field we want is NIPO, that's power in watts. A kilowatt would be 1 plus 3 zeros, so 10 kilowatts is 1E4. And because we want 10 kilowatts or under, we'll use the less than or equal to sign. So that's what we're going to do. Let's go into ProQuest Dialog and do this search in Inspec. Now, before we do this search, it seems to me that there's kind of a threshold question here of what words we want to use. In this case, it's really, I think, not very obvious. I was talking about wind power machines, but what really is the right word for those? My wife calls them windmills. Perhaps that is a good word for them. But that's something I think we'd want to look into with a search like this. And a good tool in that situation would be to use the thesaurus. You can find the thesaurus either here in command line search, in advanced search. The thesaurus link is over here. We're going to do our search in command line. But there are about 32 thesauri in the ProQuest Dialog system. There are about 30 databases that have their own unique thesaurus. Each of them works a little bit different from the other, but they're quite similar. And once you've used one or two of them, you'll get accustomed very quickly to using the thesaurus. So let's use that here. I'm going to click on thesaurus. And I'm going to start by looking for windmill. Click Find. And this is interesting. We see these various possibilities here. Wind is probably too general for us. Wind power, that would be good. I'm going to put a check mark there. Wind power plants, even better. We don't want wind tunnels. Wind turbines, excellent. Now, this is just what we were looking for. We didn't know that term going into the search, but here we've spotted it. I'm going to put a check mark there. Let's look at the sticky notes. This is where the thesaurus shows you what the term is used for. And here we see related terms are wind power plants. We've already got those selected, so we don't need to do anything with those. We don't really want hybrid power systems or pitch control, but by clicking on the sticky notes, you can see what the similar or related terms are. And now I'm just going to click Add to Search, and you see what this does. We not only learned what these related terms were, the thesaurus actually created the search for us. And in this database, when you use the thesaurus to create your search, it will be looking for terms in the subject exact or exact subject field. In some other databases, it might be a different field, but that's the way it works here. So let's go ahead and run that search. We will use preview result counts. And as you can see, this gets a lot of hits, over 47,000 hits. But we're going to narrow this down further. Let's do S1 and noise. I could use the thesaurus to look for other terms for noise, but I'm thinking the records that I want here are going to have that word in them. So we've got S1 and noise and an IPO, open paren, less than or equal to 1E4, less than or equal to 10 kilowatts. We'll go ahead and run this. So as you can see, that makes a big difference. We're down to 17 hits. Let's take a look at them. So it's a much smaller number, but these will be the records that talk about noise and also that talk only about noise issues concerning these small wind generators or wind turbines that we're interested in today. And as you can see, even though there are only 17 hits, these are very good hits. These are the ones that we wanted. Even just looking at the titles, we can see that a number of them talk about small wind turbines. So we can tell right away that they're on point. But to kind of check the accuracy of our retrievals here, I'm going to go ahead and download these records. I'll make it in RTF format, and we'll go with a custom format that includes the basic publication info. That'll be the title. And we'll also download the numeric indexing field so we can see what that shows. And here we can see by looking at the numeric indexing field that each of these records is within the range that we were looking for. It's either going to be 10 kilowatts or less. There's 8, 2.4, so these are all for the small wind turbines. So this was an excellent use, I would say, for both the thesaurus and for doing our range search with numeric indexing. So I hope that has been interesting for you. Let's go back a bit to our slideshow, because I want you to know that we do have here for your reference a summary of what we've just done live, and in addition here you will find all of our contact information. I'm giving you our phone numbers. That would be 800-3-DIALOG, the email address for support, customer@dialog.com, and also my own personal direct email, theodore.karen@proquest.com. I'll put that in the program description as well for this recording, so that you can feel free to reach out to me directly if you can use any help with these searches. Here is the address for the Pro Sheets, the address to sign up for webinars, including live webinars or additional recordings. We encourage you to look into that. We're happy to help you with it. And the last link we see here is for the Inspec webpage, their own webpage. You will find a lot of support material there, not so much for how to do your searches on ProQuest Dialog, but rather about the database itself, including, for example, a complete list of all of their journals and coverage. I hope, as I said, that you have found this interesting. This is the kind of search technique that you may not need to use every time you use ProQuest Dialog. It's not an everyday kind of need. But when the situation comes up that you need to do a search of this type, hopefully you'll be very glad you took the time to look into this and to have this technique kind of in your toolkit and be aware that it's there and how to do it. Thanks very much and enjoy the rest of your day.